Good morning, everyone. Last class for the AP exam. Even though no one's here yet, I feel like I have to say something since it already started recording. Good morning, guys.
Morning.
I'll wait till start till 11:05 like usual. Oh, most people would be here by now. Sydney, Jonathan. I guess that's Peyton. Hayden. Well, today's class, with it being the last class before the AP exam, is meant for you to ask any final questions you have about the exam process on Tuesday, or about any questions you have from any of the assignments, or any questions you have about any particular topic. And then if there is time, I thought it'd be fun to do a Kahoot. We would have done it one today if we were actually in school, the last Friday before the AP exam. Well, there's only 8 of us. I'll wait till 11:10. There should be more people coming. I figured Samra would be here. She asked me a question she wanted me to go over. Okay, well, it's 11:10. Well, I think we have less people here now. Down to only 7 again. Whatever. Okay, well, let's begin. First thing I want to tell you about, hopefully you already know about it. Picking up your cap and gowns next Friday. So this is on the school website, but it's also been sent out via email. It's on Twitter. That's where I'm at right now. So you'll get your cap and gown next Friday there at school based on your last name. There's the Senior Sunset Recognition event next Thursday, 7 to 9. They'll give out more information about that later on. But I'll be there. Lots of teachers will be there. It'll be like a parade through the parking lot. More exam info. This is the same slide I've shown every time since I got this information. AP coronavirus updates.collegeboard.org. Your exam is Tuesday at 1. You need to log in at 12:30 with the information you're given on Sunday. There's a bunch of other helpful links, but all of these are also on the Google Classroom. I posted those, I think, on Tuesday. Before going on and doing any calculus questions, does anyone have any questions about the exam process on Tuesday?
So basically we can just use whatever we want.
Pretty much. They do say two major restrictions, though, are you cannot be using any sort of shared Google Drive or shared Google Doc with other people. That is not allowed. As well as they are trying to restrict looking up stuff during the exam. So I mean, you could have out all of your notes, but they're restricting internet lookup during the exam. Although, if you feel like you have to look up something that's not even there with you during the exam, then that will probably be wasting time having to search for something, as well as then I would say you're not very prepared for the exam anyways. I mean, you have notes from this year, homeworks, tests, all the stuff we've done for the past few weeks, the giant review sheet we did. Feel free to have that stuff out with you for sure. You can print out other stuff ahead of time, if you have a printer or have other stuff available. But definitely don't plan on looking something up on the internet during the exam or have anything shared with other people during the exam. Those are really the only restrictions to what you can use. Any other questions?
So it like allows you to like switch screens, right? Like if you want to go and copy and paste your work.
Yes. Yes, it does. It also allows you to do like a split screen where you can have the exam and be able to see the questions on half your screen, and you can have like your Word document or notes document on the other half of the screen. So you could do that as well. Any other questions about the exam process on Tuesday? Okay. Well, someone already did give me a question. Samra asked about IVT and MVT, and specifically how to know when to use them. So I'll answer that question first, and so it's a question I already have. Let's make this a little bigger. Going over, I also have a free response question that specifically answers this as well. So that uses both of these, and so we can address practically through a free response question when to use these. It's a quick review of what they are. They're both theorems that have conditions and conclusions. So for IVT, its conditions its only conditions are that, well, no, there's two conditions, not that f of x is continuous on interval from a to b. And its second condition is that k, which is some y value, k, which is some y value. I'm just using k because that's what I used when I originally taught this to y'all. K is between f of a and f of b. So that's the conditions for IVT. Then the conclusion to IVT. There is a C in the interval from A to B. Where f of C equals k. And that is the key thing here that helps us figure out which to use IVT or MVT. In MVT, its conditions that the function is continuous on the closed interval A to B and differentiable on the open interval A to B. All that really means, the closed versus open, is just that the differentiability just doesn't have to, it doesn't have to be differentiable at the endpoints. It's okay if it's not differentiable at the endpoints. This still works. And that's the only conclusion, the only conditions for MVT, continuous and differentiable. Then the conclusions is that there is a C in the interval from A to B where, okay, I'm going to put it in words and an equation, where the instantaneous rate of change I'm just going to put ROC for rate of change equals the average rate of change. An instantaneous rate of change, we should recognize that phrase as the derivative of the point, meaning f prime of c equals, then average rate of change, that's just slope, meaning the slope at some specific point equals the slope over the entire interval. So then this here would be f of b minus f of a over b minus a. Well, f of b minus f of a over b minus a, that is some number. And if that number equaled some k, then this is saying that f prime of c equaled k. So that's one difference between how they will ask these questions and how we would know to use which one. What I mean is, if we look back at IVT, all it's saying is that if it's continuous and there's some y value between the two different y values of the endpoints, then there has to be some x value that's going to output that y value. Meaning, we would use IVT if we were trying to guarantee a certain output value of the function. So if we're trying to guarantee a certain output value for the function, we're trying to guarantee that the function really does hit a specific y value, a specific output value, a specific f of x. Or another way to word that is if we're trying to determine, scroll down a little bit. If f of x attains a specific value. So IVT is used when we're trying to figure out and determine if the original function f of x outputs a specific value. Trying to determine if the original function f of x ever attains some specific value. While MVT is trying to determine if the derivative ever attains a specific value. If the derivative, which is the slope, is ever some specific value. So to write that, trying to guarantee f of x has a mean value theorem is used to try to determine and guarantee that the function has a specific slope at some point, or specific derivative. That's not how you say it. I put an I right there in derivative. What's happening? Or if you're trying to figure out where the average rate of change equals the instantaneous rate of change, MVT would be used to figure out if the average rate of where the average rate of change equals the instantaneous rate of change. So IVT, looking to see if the original function attains some specific value. MVT, looking to see if the derivative attains some specific value, looking to see if the function has a specific slope somewhere. So let's look at a free response question that uses those. So this is from the 2007 free response questions, number 3. They give this table with f of prime g, g prime. We are told that f and g are both differentiable. Well, if they're both differentiable, that then automatically means that f and g are also both what?
Continuous?
Continuous, yes.
Yeah, continuous.
So differentiability does imply continuity. Differentiability does imply continuity. So if something is differentiable, it's then automatically continuous. And this is one way that they will usually assess that. They'll tell you if something is differentiable, but then somewhere you say that it's continuous. You don't even really have to say because it's differentiable, but you do have to say that it's continuous and recognize that is happening. So then the table gives the values of the first derivatives of the functions. Function h is f of g of x minus 6. Part A asks, explain why there must be some value r between 1 and 3 where h of r equals -5. Well, how they worded that is r an x value or a y value?
X.
Yeah, r is an x value. So r is an x value that we're told is between 1 and 3. So we're just dealing with the interval between 1 and 3. And we are asked to explain why that there has to be some r value, which is an x value between 1 and 3, where h of r equals -5. Meaning we are asked about why there has to be a situation where the original function does output -5. Well, based on this, would we use IVT or MVT?
IVT.
Yes, that would be IVT. And I mean, we knew ahead of time we were using these because I'm explaining IVT and MVT, but again, the indicator that we are using IVT is we're wanting to show that the function outputs a specific value because we're asked to explain why h of r must equal -5. So if you're ever trying to show that the function attains or outputs a specific value, that is IVT. So in using IVT, we've got to first show that the conditions are happening. Well, is h of x continuous?
Yeah.
Yes, it is. So let's just say that h of x is continuous. There should be another u there. H of x is continuous. That's the first part of IVT. We also have to show that k is between f of a and f of b. By k, I mean -5. That's the k from the theorem that I gave you. So to figure that out, we have to figure out what f of a and f of b are. Well, what are a and b in this scenario?
1 and 3.
Yeah, 1 and 3. So we need to figure out what f of 1 is and f of 3. Well, not f, h. Gotta figure out what h of 1 is and h of 3. So h of 1. Well, h of 1 is f of g of 1 minus 6. Okay, well, g of 1 is 2. And then f of 2 is 9. 9 minus 6, that's 3. And then h of 3, f of g of 3. G of 3 is 4. Then f of 4 is -1. -1 minus 6, -7. Well, since h of 1 is 3 and h of 3 is -7, the -5 that we're asked about is less than h of 1, and it is greater than h of 3. So it is between those points, and since it's between those points, IVT guarantees there is an R go ahead and put the between 1 and 3, where h of R equals -5. So anytime we use either one of these theorems, we show that the conditions are happening, and then we just state the conclusion. This right here, this is the conclusion that I wrote on the previous slide. That there is a C between A and B, where f of C equals K. Just instead of F, we have H. Instead of C, we have R, just because that's the letters they used. So we showed that the conditions are happening. And then we just state the conclusion. On part B, it says to explain why there must be a C between 1 and 3, where h prime of C equals -5, where h prime of C equals -5. Well, here we're asked to show that the derivative equals -5 somewhere. Well, the derivative is the slope. So we're asked to show that the slope equals -5 at some point. Well, that should indicate mean value theorem, because mean value theorem is trying to guarantee that the function has a specific derivative or that a function has a specific slope at some point. And so in part B, we're going to use mean value theorem to show that h really does have that derivative somewhere. Well, first we need to say that the conditions are happening. Have we already stated that it's continuous somewhere on the page?
Yes.
Yeah, we did. We said it in part A. If you say something like that in part A, you don't have to re-say it again in part B. Not going to hurt. Definitely wouldn't be an issue for me to say that h of x is continuous and differentiable. But I did not have to here on part B, because we already told it's differentiable in the problem, and we already said it's continuous in part A. So I didn't have to, but definitely would not hurt. Well, now we need to figure out what that conclusion is. Show that that's actually happening. So we're going to apply the equation of mean value theorem, which says that f of b minus f of a over b minus a will equal -5. So we need to figure out what h of 3 minus h of 1 over 3 minus 1 is. Well, h of 3, we already said what that is. H of 3 we found to be -7 minus h of 1, we found that earlier to be 3 over 3 minus 1. 3 minus 1 is 2. Oh, that is -5. So that really is happening. We see here this is the average rate of change. And by the mean value theorem, the average rate of change does equal the instantaneous rate of change. So then IVT, this average rate of change, which equals -5, would also equal h prime of r, for r between 1 and 3. And that's all we would really need to say there. Samra, does that answer your question and help? I think the key thing to know when to use them is that IVT will be used if you're asked to show or trying to show that f of x equals some specific value, that the original function outputs some specific value, well, mean value theorem would be used if you are asked to show and are trying to show that the derivative equals some specific value, or that the original function's slope has some specific value. Okay. Well, any other questions about any concepts or questions on the assignments that you want me to go over?
On the super FRQs,
Yeah.
F on number 1.
FRQs number 1. Okay. Okay, F number 1. So let me do this so I can write on that. There we go. So in number 1, B of T is the rate at which coal is burning. S of T is the rate at which coal is being added after the first 2 hours. Well, I can guarantee you a question like F will not be on the exam, but I will go over it because we did learn F. So I definitely will still answer your question, but something specifically this will not be there.
Wait, why not?
Asking for average rate, and based on how they gave the problem, the only way to find the average rate would be to use the integral formula for the average value of a function, where the average function value is 1 over b minus a times the integral from a to b of f of x dx. That formula for the average function value. And so that's what we would use here. It's asking for the average rate the coal is burning. Well, the rate at which the coal is burning, that is B of T. So the average function value, the average value of that rate would be just 1 over 8 minus 0, integral from 0 to 8 of B of T dt. If we had more information, for instance, if we knew a function, if we had a function for coal being burned, I mean, sorry, like if we had a function for that integral, meaning if we had a function for its antiderivative, not the rate at which it's burning, but how much coal we had leaving at individual times, then we could do something like B of T minus, B of, I guess, B minus B of A over B minus A. We could like find the average rate that way if we had the different equation. But since we were just given that function, the average value of the rate of coal being burned is the B of T. Average value of that function, the only way to do that is the average value formula, and that's in Unit 8, which is no longer on the exam.
Okay.
So we did cover some of Unit 8 before, earlier. So we did cover this, but Unit 8's no longer on the exam. Most of this file was made after they made those changes. So most of this file is specific stuff that will be on this year, or at least could be, not will, but could be on this year's exam, but that's one instance of something that won't be. But we did learn it, so, but it won't. Any other questions?
I'm good.
Well then, even though there's only 8 of you, do y'all still want to do a Kahoot?
Yeah.
Okay. Well then, like last time, you'll need 2 devices so that you can see the questions on the Zoom screen, and then use your phone to do the answers. Okay. I'll share my screen and we'll do the Kahoot. Here we go. Okay. Oh, here we go. Code is 473258. Code is 473258. What sideways? Hey, I'm playing too.
Uh-oh.
I'm the hunter. Isha, are you playing?
I can't. I'm actually in like 3 meetings.
That's funny. Okay.
All right. Sorry.
That's not a big deal. Okay, let's start then. This goes to the derivative of inverse rules. the rule for derivative of an inverse. So all we're told is that it's twice differentiable, which doesn't guarantee that it's triple differentiable. That guarantees the first derivative exists and is continuous, and it guarantees the original function would have to be continuous, but doesn't say anything about the third derivative, which is what choice red was. Good. Hey, we just talked about this. Although it's kind of tricky. Okay, if you chose green, I'm not sure why you chose green. So we're told, suppose f of 1 equals -3, f of 2 equals 4, so then the average rate of change would just then be 7, because 4 minus -3 over 2 minus 1, that is 7. So the average rate of change is 7. And mean value theorem would give the conclusion that f prime of c equals 7. But what is the condition for mean value theorem? That they did not tell us what's happening. We are not told that it's continuous. We're not told that it's differentiable. So we cannot make the conclusion that the instantaneous rate of change has to equal the average rate of change. The answer is B, because none of those have to be true. Yellow.
What if it told us that it was?
What?
What if it told us that it was differentiable?
Oh, if they told us it was continuous and differentiable, then yellow, yes, would be the answer. And yellow still could be the answer, but it doesn't have to be. You notice the key thing in their question was the word must. They say which one must be true, and yellow doesn't have to be true because we have no idea whether it really is continuous and differentiable or not. Yellow
I'm
would be
confused.
right. Yellow
I'm
would be
confused.
right if we were told it was continuous and differentiable. Does that make more sense?
Yeah.
Okay. Since it's multiple choice, it should be easy. We're taking an integral, meaning all the choices. If if you take its derivative, should give you the question. As I was saying, since it was multiple choice, it should be easy. We want to just take the derivative of the choices and see which one gives us the original. That's the easiest way to do this particular problem. I mean, I know Tuesday is not multiple choice, and so if you were to actually do this Tuesday, well, you want to essentially do substitution. If u was x over 4, you'd have to then get du and all that. But you can also just think of reversing chain rule. If you'd reverse chain rule, that means you'd have to divide by the derivative of the inside function. Well, the derivative of the inside function is the 1/4, so you'd have to divide by 1/4. Well, dividing by 1/4 is multiplying by 4. This is asking the dominant FRQ if what they wrote right there is what you got for your answer. What is the way to leave your answer written? If you have something as nasty complicated as that, which is your final answer, there is no reason to waste time simplifying, as well as you could make a mistake simplifying. We've gotten pretty good at calculus, but still struggle with some basic algebra. So avoid simplifying if you can. If you have something like that, and that's the final answer, cosine pi over 3 is just a number. All of those things are just numbers. So leave it like that. Don't simplify if you don't have to.
Wait, no, that one is true. I'm gonna cry.
So the reason it is red is because if something's a point of inflection, the second derivative could also be undefined or non-existent. Second derivative could not exist or be undefined. If you have a point of inflection, the second derivative for sure changes sign. Like that's the definition of a point of inflection. Green is the definition of a point of inflection, that the second derivative changes sign at that point. Well, if the second derivative changes sign, then that would inherently mean that it is a local max or min of the first derivative. Meaning yellow could also be considered the definition of a point of inflection. And then if it is a local extrema of f prime, then it would inherently be a critical point of f prime. So blue, yellow, and green are all equally the definition of a point of inflection, but a critical value of f prime could be when the second derivative is 0, but could also be when the second derivative is undefined. again, if we were to do U substitution, we would now also get that du is 2 dx.
Oh.
And we would want to replace dx. So we'd have to get dx by itself. So we would divide by 2 on both sides, getting 1/2 du equals dx. And so that's where the 1/2 comes from. We're reversing chain rule when we do U substitution. So divide by the derivative of the inside. I'm going to skip this one since that's average value. It's not on the exam. Rolle's theorem, I didn't answer it earlier, but it's just a special case of mean value theorem. Rolle's theorem is just a special case of mean value theorem. So it's for sure going to have the first same two conditions as mean value theorem, but with one other condition. Yes, good, it is. So red is the one extra condition that Rolle's theorem has for mean value theorem. I didn't really address Rolle's theorem earlier when I was talking about IVT and MVT because if a problem could use Rolle's theorem, then it therefore also could use mean value theorem. So any sort of free response question you ever see, if Rolle's theorem would work for the justification for what they're asking, mean value theorem would also work. So you wouldn't have to use Rolle's theorem. You could just use mean value theorem. So if you're unsure about how to use Rolle's theorem, you don't have to worry about it because mean value theorem would work anywhere Rolle's theorem would. But green and yellow, those are the conditions for mean value theorem, and then red is the extra condition for Rolle's theorem, where f of a equals f of b. Blue is actually the conclusion of mean value theorem, that if these other three things are happening, then f does have a local extrema between that interval. Don't think too hard on this one. If we read the entire choice for red, it says mean value theorem for integrals. The mean value theorem for integrals just says that there's some x value that will actually equal the average value of the function. And so it doesn't have to, and the average value formula is an integration formula. So mean value theorem for integrals, it doesn't have to be differentiable. It has to be integrable. You have to be able to take the integral. You don't have to be able to differentiate it for mean value theorem for integrals. And both extreme value theorem and intermediate value theorem, differentiability is not required. Continuity is the only thing required for those. This right here is an algebra 2 level problem. Yellow says natural log of x, and on natural log, the range is all real numbers. Range is all real numbers. Don't get domain and range confused. Well, I don't get why people chose either blue or yellow. I thought the second most picked one would be infinity. If you just plug 2 in, 3 times 2 squared minus 1, that'd be 3 times 4 minus 1, which is 11. Plug 2 into the bottom, you get 0. So you get 11 over 0. So I don't know how you got 3 or infinity, but 11 divided by 0 doesn't exist. That's undefined. So you really could have picked infinity. This particular question had infinity as also correct. Good, good. Glad most of us chose that. If we just go through the other ones, red only says that it's concave up in that interval. Well, if something, we're asked which is not sufficient justification that f has a local minimum at x equals a. Well, if all we know is that it's concave up at x equals a, well, to be a local minimum, we know it also has to have a horizontal tangent there. We know that it has to have a slope of 0 at that point, and if all we know is that it's concave up, that's not sufficient. So one thing to keep in mind for the exam, especially since it's only for response now, the exam graders or the exam readers, they don't know what's in your brain. So you may think it's obvious, something's obvious, or you may be thinking of something and just not writing it down, but they don't know what you know. So just write almost everything that could apply or that would need to apply for a certain situation. Just writing that something's concave up, if you think that it's obvious that the derivative is 0 there, and saying concave up is enough, well, if you never actually wrote that the derivative is 0 somewhere, well, then that's not enough. It would need to be said so that they know that you know that. I'm skipping this. This is volume. We never did volume. And we'll just go to question 20. It's taking a while. I think I'll post this Kahoot as something for people to practice on.
Yeah.
Google Classroom or the calendar, which one's easier. Guys. Blue, there's no rule for integral of natural log unless you're in Calc BC and memorized it. Integral of natural log needs something called integration by parts. So we don't even know how to do blue. We're getting them backwards. And that green's also getting them backwards. The only issue with yellow is the integral of 1 over x should say natural log of the absolute value of natural log. So the only issue with yellow is there should be an absolute value inside the natural log. 19, and then we'll do 20 and we'll be done. Good. So if we go through these, red, we're asked which of these situations would we use an integral? Or might we use an integral? And red says you want to see if the function is continuous. Well, when we learned about continuity, we had no idea what an integral was yet, so that would definitely not make sense. Blue, you know an amount and you want its rate. Well, that is describing a derivative. If you know an amount to something, a function for an amount, and you want the rate at which it's changing, well, that's derivative. Yellow says you want to see how fast a rate is changing. So we're wanting to see how the rate, what's the rate of change of the rate? Well, so yellow is actually talking about the second derivative, the rate of change of the rate. Yellow's the second derivative. Green, you know a rate and you want a change in amount. That is an integral. So it's going backwards. So what we see blue, you want a rate and you have an amount. So if you switch that, you know a rate and you want to change in the amount, that's an integral. One more question, then we'll be done. Question 20. FT represents the rate at which something's price is changing. When is the price increasing?
Got that right.
Oh, I got that wrong. I forgot the F was a rate. So that's why it's blue, because F is the rate at which the price is changing. So the price is increasing when its rate is positive. Well, the rate at which the price changes is F. So it's when F is positive. So gotta make sure you read the questions carefully, which John did. Good job, John. Well, it's now 12:12. Let's be done. Good luck on the exam, guys. Have a great weekend. Be relaxed. Be prepared. Goodbye.